welcome back to Manish Kumar channel. So today we are going to do examples on roots of complex numbers. Okay, so if W0, W1 and so on Wn minus 1 are the nth roots of unity, then show that 1 over W0, 1 over W1 and so on 1 over Wn minus 1 are also nth roots of unity. Also find their relation with the original roots. Okay. So we know that the nth roots of unity are the solution to the equation z power n equal to 1, and they are given by wk, where k equal to 0 to n minus 1. There are total n roots, which is equal to e power I to k pi by n, where k varies from 0 to n minus 1, right? So taking the reciprocal, which we are supposed to figure it out in part A. So 1 upon Wk, which is nothing but 1 by the Wk value. And then since this is going to be e power negative I to k pi by n. So also one interesting property is if you see the relation here in these two, this is just the complex conjugate you can think of, like, right? And the nth roots of unity, if you take the modulus of this, right, which will produce you 1, it means that the 1 upon wk also lies on the unit circle, right? And the roots are the reciprocal basically, right? Complex conjugate from the original one. So the relationship with the roots, which we have already seen, the reciprocal 1 upon wk is the complex conjugate of the original one. So they are precisely the complex conjugate of the original roots of unity. Hence this set is just the original roots reflected across the real axis, right? So how we can see them geometrically? So geometrical interpretation, if you see here, the original root W0 and 1 upon W0, because you know W0 is 1. So 1 by W0 is going to be 1. So they are on the same place, right? Blue and red. Okay. Now W1. W1 is in the upper half of your real line, right? This line. So W1 and 1 by W1 is just the reciprocal. X-axis will play a role of mirror. So now your second root will be 1 by W1, which is here, right? Similarly, the third root W2, which will be 1 by W2, will be here, and so on. So this is just the example for n equal to 6, right? So n equal to 6 if you take, then you will get 6 roots, and they are, you see, W3 is just the 1 by W3, and W4, this W4 is going to map, you see x-axis will play a role of mirror, so this will go to here, 1 over W4. This will come here, right? So like that. So W1 will be here. And similarly, W5, if you see W5, W5 will go in there. It means that whatever the roots are there in the upper half will map into the lower half, right? And whatever the lower half roots are going to map into the upper half, right? So let us do one more example. If W0, W1, W2 and so on Wn minus 1 are the nth roots of unity, then show that 1 over 1 plus W naught, 1 over 1 plus W1 and 1 over 1 plus Wn minus 1 lies on the vertical line x equal to half. You see what we did before, 1 over Wk was lying on this circle, right? But when we modify something 1 upon 1 plus wk, right? So this is lying on the line, not on circle, right? So this is a very important observation. Slight change if I do, then it's no longer mapping on the circle. Okay, so we know nth roots of unity are given by wk, which is equal to e power 2 pi ik divided by n, and where k runs from 1 to n minus 1. So we can also express it cosine 2 pi k by n plus I sine 2k pi by n. And let us do the calculation because we are interested in 1 over 1 plus wk. So 1 over 1 plus wk will be like this. And now we are going to do you know, complex conjugate multiplication on both numerator and denominator. So we are going to just change the sign, see here, and then we are going to just do the perfect square here, and which is the denominator will comes like this. Now what we are going to do, we are going to collect the real part of this and imaginary part of this. So real part and imaginary part we are going to collect. So in real part, if you see this factor divided by this factor, and imaginary part this factor with negative sign along with this denominator. So how the real and imaginary parts looks like. So real part of 1 over 1 plus wk is nothing but this, and since 2 is taken out common from this denominator, so this is exactly equal, so they are going to get cancelled, and then we are going to get half. This is constant, right? And which is real part means x equal to half, right? So now if you see, compute the imaginary part. Imaginary part means if you see imaginary part, you see here sine 2 theta type, sine 2 theta type, right? So we are going to use the formula 2 sine theta and cosine theta. Sine 2 theta is, and similarly we are going to write cosine 2 theta equal to 2 cosine square theta minus 1. So which is going to be this, and then after solving this we are going to get minus 1 by 2 tan pi k by n. So this, if you see, this is variable, no longer constant, right? Hence all the points 1 over 1 plus wk lie on the vertical line x equal to half. So if you see the geometrical interpretation, so this is the line x equal to half. So you know w0 is 1. What about 1 upon 1 plus w0? 1 upon 1 plus 1, which is equal to 1 by 2. So this root, the blue color root will exactly lie on half, this map here, half, x equal to half, this line, red one, right? And if you see here, all the roots are on the line. The most important part here is the upper half from this real axis. All the roots which are above are mapping below, right? So for example, if you see w1 map to this line below because of the complex conjugate type of property is going to appear, right? And similarly w2 and so on. Here if you see w4 are mapping here, so all are just you know x-axis will play a role of mirror and all are lying on the straight line, right? So thank you very much, thanks a lot.